All right, guys, one last topic, one last video today. We are doing now topic number 5. Understand parallel and perpendicular slopes and how to calculate them. So a very simple concept actually. Parallel lines, if they're going to be parallel, they should have the same slope, right? So parallel lines, slope is equal. So how do you calculate it? Keep the slope the same, easy. Now perpendicular lines, if one is going up, the other should be going down, right? So one's negative, one's positive to be perpendicular. And then if one has a slope of 2 over 1, I mean 1 over 2, then the perpendicular one is going to have negative 2 over 1. So it's going to be opposite reciprocals, we call them. That was a terrible picture. But that's the idea. Anyway, the picture's not working. I'll show you the picture later when we do a question. So how do you calculate a perpendicular slope? You just flip the slope fraction upside down and then switch the sign. So for example, if your slope was 1/2, the perpendicular slope, which we can call m, the little perpendicular sign here, this little upside down t is the symbol for perpendicular. So m perpendicular would be switch the sign negative and then flip it upside down 2 over 1. Right? Or if it was 3/2, it would be negative 2 over 3, something like that. That's it. Now, there's exceptions to the rule, which are vertical and horizontal lines. Obviously, vertical lines are parallel to each other, right? And horizontal lines parallel to each other there. And then vertical lines and perpendicular lines are perpendicular to horizontal lines. So they're perpendicular to each other. If they're the same, they're parallel. Opposites are perpendicular. As far as equations of the lines, vertical lines have equations with x equal to some number. And like this. Horizontal lines have equations like y equal to some number. And if you think about it carefully, it makes sense, even though it seems kind of a little bit counterintuitive because, like, isn't the x-axis the horizontal axis, right? You think? But the reason why it works out that way is because if I look at this, x, y, and I keep the x value the same all the time, so here's like a particular x value. So keep the x value, and I have a bunch of points with the same x value, they're going to lie in the line of a vertical line, right? And similarly, if I take some y value, let's say my y value right here, and I take a bunch of points that have that same y value, well, they're going to lie in a horizontal line. So that's the reason why it seems like the letters are kind of flipped. X equals for vertical, y equals for horizontal. Okay, that's the theory. Let's go on to the questions now. 10 through 14, we got 5 more, and then we're out of here. And I prepped it on my other page. So, oops, wrong one. Let's go 10 through 14. Okay, the line goes through 1, 4 parallel to y equals negative 3x. This is going to be simple, guys. This is, okay, right here, look at this thing. It's in slope-intercept form already, right? So this negative 3, that's your slope. So the original slope was negative 3. I want a line that's parallel. So parallel slope means just keep it the same. M is still negative 3. And then here's my x1, y1. So I can go straight to plugging into point slope form. Just like we did in the previous video. So it's going to be y minus 4 is negative 3, x minus 1. And that is the equation of my line. Now instructions wanted us to convert that to slope-intercept form. So, all right, y minus 4 is negative 3x plus 3. And then add 4 to both sides. Y equals negative 3x plus 7. Okay, real fast. Let's just sketch that thing. Here's x, here's y. Colors are all over the place. 1, 2, 3, 4, 5, 6. Oh, man. Sorry. Oh man, that didn't work because it copied everything. 1, 2, 3, 4, 5, 6, 7 would be like around here. Okay, and then negative 3 slope. So 1, 2, 3 down, 1 over. Okay, so something like this. Something like connecting these two dots. Sorry, it's going through everything, guys. But that's the idea. You know how to graph it, right? Just plot the intercept, connect the dots. Sorry, my graph is not fitting here. I didn't give myself enough space. But I'm gonna move on for the sake of time and because you know what's going on. Okay, line goes through 6, 1, parallel to 5x minus 7y equals 35. This, by the way, is what we call standard form of an equation for line linear equation. But to get it to something that we're more familiar with, we're gonna solve for y. So let's do a little side work. Negative 7y is equal to negative 5x plus 35, right? Subtract 5x from both sides. And then to get rid of that negative 7, divide both sides by negative 7. So y is equal to, this part I'll show because I think I might lose some people if I don't. So divide both sides by negative 7. So that's going to be just a y on the left, right? Negative 5 divided by negative 7 is going to be 5 over 7. And then, when you're dividing by something, divide each individual piece. So 35 divided by negative 7 is going to be actually a negative 5. 35 divided by 7 is 5. Oh, look. That part's in. Actually, no, never mind. That's not important. So it's parallel to this. That means the whole point of that part is just to figure out what my slope was. And that's my slope right there, the 5/7 portion. Here's my x1, y1. So now I can plug it into my point slope form. Y minus y1 is mx minus x1. That's y minus 1 is 5/7 x minus 6. So that's the equation of my line. It asks for slope intercept form. So two steps. First, distribute that 5/7 minus 6 times 5, what? 30 sevenths. And then add 1 to both sides. Y is equal to 5/7 x minus 30 sevenths plus 7 over 7. Should be minus 23 over 7. Right? Subtract 7 over 7, I get 30, yeah. Okay, so that's slope intercept form, but that's not very nice to graph there. So I'm gonna, for graphing purposes, I'm gonna go back to this guy. And what was my point? 6, 1 is my point. So here's x, here's y. 1, 2, 3, 4, 5, 6, 1, right there. And then my slope was 5 over 7. So 1, 2, 3, 4, 5 up, and 7 over would be 1, 2, 3, 4, 5, 6, 7 over here. And once again, I'm short on space. I was a little stingy with making space. Okay, this one kind of actually works. So what was that? 1, 2, 3, 4, 5, 6, 7. Okay, that's where it was. And over here is 5 up, yeah. 1, 2, 3, 4, 5, yeah. So there's my second point, and then I'm just gonna connect those two dots. Or at least try to. That was a little better. Okay, there it is. Okay, how many more we got? We got 3 more to go, but the last 2 are actually easy because the last 2 are the horizontal vertical lines, so those will be simple. Okay, perpendicular to y equals to 2/3 x plus 5. That's nice because the original m was 2/3. That means my perpendicular slope. Wait, did I answer that one correctly? Yeah, last 2 are both parallel. Yeah, okay. Just double checking myself. Okay, perpendicular would be opposite reciprocal, right? So 2/3, flip it upside down to 3/2, and tack on a negative, either in the top or the bottom. So that's the slope that I'm looking at. Here's my x1, y1. So that's a 1. So y minus y1 equals to m, in this case perpendicular. x minus x1. It's going to be y minus -3 is equal to -3 halves x minus 2. Or y plus 3 is -3 halves. That's a terrible looking 3. -3 halves x minus 2. That's the equation for my line. Okay, now change it to slope-intercept form. Y plus 3 is equal to -3 halves. Oops, -3 halves x. -3 halves times -2. The negatives cancel out, making it a positive, and the 2's cancel out, so that makes it a 3, plus 3. Oh, how about that? Okay, -3 on both sides. I get y is equal to -3 halves x, because the 3's cancel each other out. So there's my slope-intercept form. Okay, this time the graph, let's just give myself more space. Let's shift everything down here. Okay, so I'm looking at -3 of x right through the origin. Right, the intercept is at 0, 0 because there's no number there, it's plus 0. So here's the intercept. -3 halves means 1, 2, 3 down, and 1, 2 over. So there it is. And then I just connect the dots. If I can. Okay. Okay. 2 more, and like I said, these are the easiest ones. Okay. Line goes through 2, 5, perpendicular to x equal to 4. So perpendicular, remember, for perpendicular to x equal to 4 is a vertical line, remember? And perpendicular would be a horizontal line. So the formula is going to look like y equals to some number. Now this is kind of a special case where you don't have to go through any rigmarole. You just have to find what is the y value, and the y value is 5. So it's going to be y equal to 5. That's it. Okay, let's draw the picture to double check that I'm correct in what I said. So here's the x-axis, here's the y-axis. Okay, let's just plot this original. One in red. X equal to 4. So 1, 2, 3, 4. Here x equal to 4. That's 4. Here are some points where x is equal to 4, and if I connect the dots, I get that vertical line in red. Right. So that's the original. Now I'm going to do my formula y equal to 5 in blue. So where's 5? 1, 2, 3, 4, 5. Right there. So here's y equal to 5. Here's some other points where y equal to 5. And here's one where y is equal to 5. The point 2, 5, which I had to pass through, right? So now, check that out. Oh, okay. Yeah. And if I was to extend this line, they cross, and they cross at a nice right angle. So perfect. That's it. Okay, the line that goes to -1, 3 perpendicular to y equals to 9. It's perpendicular again. So that means it's going to have to form x equal to some number. And what is the x number? Right here. X is -1. So that's it. There's no, by the way, for both of these, there's not what I wouldn't say there's a slope-intercept form really. I mean, I suppose you could argue this is slope-intercept form because it's y equals to something, but you know, the slope is 0. So it just kind of disappears. In this case, there is no slope because I have a vertical line. -1, x is -1, so here's -1 right there. And here's a bunch of points where x is -1. Whoa, that's cool. And then -1, 3 in particular. -1, 1, 2, 3. That's this point right there. And I do go through it, and it is perpendicular to the line y equal to 9. Because y equal to 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere over here, like a horizontal line, right? And it would indeed cross perpendicularly. Okay, guys, that is the end. hope you have a great day and hope you have a great week. See you next time.